Hi everyone. In this ETS bus stop tutorial, I will demonstrate the steps to define a class and the necessity of overriding the toString, equals, and hashCode methods. This tutorial assumes that you already know how to create a Java project with IntelliJ IDEA. I already created an empty project, so I'll open my project and demonstrate how to create a Java class. As you can see, in the source folder, there is already a package called ca.makeevent.cmpt305. Recall that a package is just a directory structure to organize our code and to avoid naming conflicts. For this demo, I will create a class named ETSBusStop to represent bus stops in Edmonton. This dataset is publicly available at Edmonton's Open Data Portal. There are 6 attributes of the data: landmark name, address, stop ID, latitude, longitude, and location. However, we will store just the first 5 attributes as fields in this class. Since the attribute location is just a combination of latitude and longitude, I will not create this field in the ETSBusStop class to avoid duplication. To allow client code to create an instance of ETSBusStop, we will provide a constructor. A constructor is a special method that is used to create and initialize an object. A constructor must have the same name as the class name and doesn't have an explicit return type. In this example, we want to allow client code to call the constructor and pass a landmark, address, stop ID, latitude, and longitude to initialize the new instance. The constructor has 5 parameters that use the same names as the field's names. We can use the this keyword to differentiate between a field and a parameter of the constructor. This.landmark refers to the field landmark, whereas the variable landmark refers to a parameter of the constructor. The purpose of a constructor is to construct and initialize a new instance, so the body usually contains simple code, which assigns the values passed to the constructor to the field. To test this class, I will create another class called main to run the application. We simply create an instance of ETSBusStop with some values and print the busStop object. Rather than getting a meaningful output, such as the stop ID, landmark, and address of the busStop object, the print statement produces the class name, the @sign, and some number. The number is the hashcode of the instance, which in this case doesn't represent meaningful information for users. To change this default behavior, we need to override the toString method when defining our own class. Otherwise, our class will use the toString method inherited from the object class. Every Java class has the class object as a superclass, and the class object provides some behaviors that are inherited to its subclasses. When called by system.out.println, the toString method defined in the class object returns the class name of an object, the @sign, and its hashcode. That's the reason why we got such cryptic output when we printed stop1. It will be more meaningful for the toString method to return the stop ID, landmark, address, and latitude and longitude of a busStop object. When we rerun the main class, now we get meaningful output. I'm creating another instance of ETSBusStop, stop2, which is identical to the stop1 object. Then I'm calling the equals method to check whether stop1 is equal to stop2. I expect that the equals method will return true because stop1 and stop2 have identical values of their attributes. Unfortunately, the program doesn't produce the expected output. Why is that? The reason is that ETSBusStop inherits the equals method from the class object, where its implementation compares whether 2 object references point to the same object rather than examining the contents of the objects. Since stop1 and stop2 do not refer to the same instance, the equals method returns false. To change this inherited behavior, we need to override the equals method in the ETS_stop class. Notice that the equals method is public, returns a Boolean value, and takes an object type. The first step is to check if the given object is an instance of ETS_stop. If not, we can conclude that they are not equal and return false immediately. If the given value is of type ETS_stop, we typecast it into ETS_stop and compare their stop IDs. Comparing stop IDs is sufficient because stop ID serves as a unique identifier for each ETS_stop. We can see that the equals method now behaves as expected. To illustrate the role of hashCode, I'm declaring a set of ETS_stop and create a HashSet to store a collection of ETS_stop objects. As you learned in CMPT 103 and 200, a set is a collection of unique items and should not contain duplicate values. If I add two equal objects to a set, such as stop1 and stop2, it should include only a single item. However, both stop1 and stop2 are added to bus stops. The HashSet doesn't recognize that stop1 and stop2 are equal. This illustrates another important point. When you override the equals method in a class, you must also change the implementation of the hashCode method. Hash data structures, such as hashsets, rely on the hashCode of an object to determine the equality of two objects. Two equal objects must have the same hashCode. The reverse, however, is not always true. Two objects with the same hashCode are not necessarily equivalent. If we don't override the hashCode method in our class, it will likely return different values for different objects regardless of their equality. This is why the HashSet didn't recognize that stop1 and stop2 were equal and added both objects to the collection. To satisfy the contract that equal objects have the same hashCode, we need to override the hashCode method in ETS_stop. Ideally, non-equal objects have different hashcodes. To generate a hashCode, we should include all fields that we use to compare two objects. In ETS_stop, since the stop ID serves as a unique identifier, we can rely on it to generate hashCode for each instance. It's reasonable to use the class integer with a static method that returns a hashCode for an integer value. Now, when two instances of ETS_stop have the same stop ID, such as stop1 and stop2, they will have the same hashCode. If you rerun the main class, you'll see that the HashSet no longer contains duplicate values, but now stores only a single instance of ETS_stop. In summary, this demo illustrates the purposes of overriding the toString, equals, and hashCode methods when defining your own class. The toString method should return a meaningful representation of an object, which will help in testing and debugging processes. The equals method determines how to check the equality of two objects. Finally, the hashCode methods should ensure that two equal objects must have the same hashCode. This contract must be fulfilled to ensure that hash-based data structures, such as HashSets, work correctly.